Welcome back. If you're an IT pro managing enterprise data day in and day out, you are absolutely in the right place. Today, we're setting the stage for a real masterclass, an advanced deep dive into data management using Windows Server 2022. We're going to look at the exact real-world strategies IT professionals use to handle fault tolerance, dynamic scaling, and granular security. Okay, let's dive into this. Picture this scenario. You're managing a massive volume of critical enterprise data, and suddenly, out of nowhere, catastrophic drive failure strikes. Hardware dies, right? It's just a fact of IT life. But the difference between a minor blip and a total middle-of-the-night outage comes down entirely to how your storage infrastructure is architected before that failure ever even happens. So how do we avert that disaster? Well, Windows Server utilizes an incredible core technology called storage spaces. Conceptually, you can think of it like a redundant array of independent disks, or RAID, but it's implemented entirely in software. It brilliantly protects your data from drive failures by storing extra copies across the board. It does this by taking raw physical disks and grouping them into these highly manageable, software-defined storage pools.
To get you fully equipped, here is our roadmap for today's explainer. 1. Enterprise storage spaces explained. 2. Building resilient storage pools. 3. Surviving a drive failure. 4. Repairing and recovering data. 5. Expanding capacity dynamically. And finally, 6. Securing the file server.
All right, Section 1, Enterprise Storage Spaces Explained. Let's start right down at the foundation with the bare metal storage layer.
When we contrast legacy hardware RAID arrays with modern Windows storage pools, the difference is literally night and day. Legacy RAID is incredibly rigid, It's often complex to expand or recover, and it ties you directly to specific hardware controllers. Storage pools, on the other hand, offer this fluid, software-defined flexibility. You can pull together varied disks and just let Windows handle the heavy lifting of redundancy and space allocation entirely through the OS. Moving on to Section 2, Building Resilient Storage Pools. Let's look at how we actually take those raw, primordial disks offline and group them together. And this brilliantly illustrates the true power of storage spaces, the number 2. By configuring your virtual disk for dual parity, you are allowing your storage pool to sustain 2 simultaneous physical disk failures without losing a single byte of data. It's essentially like a RAID 6 setup, and it provides a massive safety net for your enterprise data. Now, when you're actually creating that virtual disk, an IT administrator has to make some very specific configuration choices to ensure future-proof flexibility. First up, obviously, select dual parity for that maximum resilience we just talked about. Second, utilize thin provisioning. This is huge because it means you can specify a massive initial size, say 8.5 terabytes, even if you don't literally have that physical space yet. It gives you incredible capacity flexibility. Finally, format the volume with RES, the resilient file system, rather than standard NTFS. That lets you take full advantage of Windows Server's advanced corruption recovery features.
Section 3, Surviving a Drive Failure. Let's pivot a bit and run through a day-in-the-life disaster simulation to raise the stakes. You open up Server Manager and boom, there it is, a yellow caution symbol right next to your virtual disk. But here is the strategic reassurance. Your enterprise data remains completely intact. While the server flags a degraded health status and warns you of the failure, that dual parity configuration we set up earlier, it immediately steps in, keeping your entire operation running completely seamlessly for your end users. No panic required.
Section 4, Repairing and Recovering Data. Now we move into the critical recovery phase to resolve that degraded state.
So, the crucial point is following this precise 4-step cheat sheet for seamless data recovery. First, you identify the exact faulty disk right there in Server Manager. Second, you have to retire the failed disk via an administrative PowerShell session. This ensures the system stops trying to write to it. Third, physically swap the drive and add the new primordial replacement disk into your storage pool. And finally, step 4, you remove the old, retired disk from the system entirely. Once you do that, the server automatically rebuilds your parity and returns to full health.
Section 5, Expanding Capacity Dynamically. Let's shift our focus from disaster recovery to scaling up and anticipating those future enterprise needs as your data inevitably grows.
This is where storage spaces drastically differs from legacy RAID. You can scale capacity entirely without downtime. You could sequentially replace smaller, say 1 terabyte disks with massive 8 terabyte models. Or, if you need a major immediate upgrade, you can attach a JBOD, just a bunch of disks, enclosure via SAS or fiber channel, and introduce dozens of disks all at once. Once the new disks are in the pool, you simply extend the virtual disk and volume to their new maximum size. Easy as that.
But wait, what happens when you scale so much that you literally run out of drive letters? Well, here's a pro tip for managing massive expansions. You can completely overcome that standard 26 drive letter limitation. Instead of assigning a letter like D or E, you can actually mount your new volumes directly to an empty NTFS or REFS folder on your C drive. This creates a beautifully organized single-volume namespace, very much like how Linux handles it, keeping your file paths simple no matter how many virtual disks you add.
Section 6. Securing the file server. Let's transition from the bottom-up physical disk layer to the logical Active Directory layer.
Let's move to and see how this builds out our complete enterprise solution. We have successfully secured the physical disks from hardware failure. Now it's time to secure the logical network access from unauthorized users.
When you install the basic file server role in Windows Server 2022, you get, well, the basics, basic sharing and volume management. But by intentionally adding the File Server Resource Manager, or FSRM role, you unlock some truly advanced management tools. FSRM elevates your basic file sharing by allowing you to enforce strict storage quotas, implement file screening to block specific file types, like unauthorized media, and generate incredibly detailed storage usage reports.
Once your server roles are in place, you obviously need to share the data. A brilliant administrative trick for highly sensitive enterprise data is creating a hidden share. By simply appending a $sign to the end of a network share name, for instance, accounts sign, you completely hide that folder from the default network browsing view. Users are forced to manually type the exact path to even attempt an access connection. It adds a really great initial layer of obscurity. Now, what's really interesting about this slide is how we lock that data down even further. First, disable inheritance, so parent permissions don't just automatically trickle down into your secure folders. Then, apply rights strictly using Active Directory security groups rather than assigning permissions to individual users. It's way cleaner. Finally, enable a feature called access-based enumeration. With this turned on, if a user doesn't have Active Directory permissions to view a folder, Windows literally makes that folder invisible to them. It doesn't just block their access, it hides the folder's existence entirely. Absolutely crucial for enterprise security.
And that brings us to the end of our deep dive. So, I'll leave you with this provocative thought. Looking at your current setup, is your storage infrastructure truly ready to survive a dual disk failure and scale dynamically without a single second of downtime? If not, it might be time to fire up Windows Server 2022 and put these advanced storage spaces and file server strategies to work. Thanks for learning with us on this explainer. See you next time.